Okay, so we're going to have a look at the CW transmitter board. I'll just switch this to the 50 ohm load. I'll go through the circuit in a moment, but so you can key it with a Morse key. If you have an old T2, an old Luftwaffe from World War II, fantastic key actually. Or you can use SW4. I'm demoing this on the version 2 of the RadioLab, but it works the exact same in version 1. The only difference is the switches are the opposite way around. So S4 is here on the version 2 and S4 is here on the version 1. So okay. Even though I've done the dummy load, it's still picking up something. It must be a trick. Yeah. Okay. So I'm going to go through the circuit, just a little bit of background theory on it, so that if you want to make some modifications or do your own thing, it should be fairly clear as to what to do. So there's a couple of things here. One is it has its own 50 ohm dummy load. It has a regulator, and the regulator is just for this chip here. So, and in theory, I think we could actually we could get rid of this, but I haven't anyway. So, so there's a lot of the kind of modern QRP sets, are using the BS170, and I've gone with that. It works, and it's kind of a proven design, so I didn't see any great need to change it. So you put 3 of them in parallel, and on the 40 meter band you're going to get about 5 watts out, give or take, depending on the transistor, but in that range. So we go from left to right here. So we have our oscillator in, and that comes from oscillator 3, which is unused in the superherd, and that's going to be set at whatever frequency we're on, minus 6 to 800 hertz, depending on your preference. Then that is then controlled. That goes into this NAND gate. So if we pull this guy to ground, then we're going to get a 1 here. So that's going to enable that, and we're going to get the inversion of the clock at this side. We invert it again. It's purely for buffering. And that then feeds into an analog switch, the way this FET is configured. And we can then enable or disable the clock going into the 3 drivers. So by putting a 1 here, the switch will turn on, and we get the signal goes into the three drivers. I'll ignore this for a moment. I'll come back to it. So if we take it, okay, we're going to use the 40 meter band. So the way it's configured, there's an extra module here that you can put in another low pass filter if you want. But if you're using the one on the board, then you basically put a jumper here and a jumper here. And so that jumper then basically connects this inductor to the drain of each of the FETs. So you're basically switching this on and off at the frequency that you want. And then the rest of it is a low pass filter. Then that goes out, that cleans up all the harmonics, and out to the output section. And the output section, so if you're just testing, I'd highly advise you do this jumper here, and then that just feeds into a 50 ohm load. But if you wanted to, you can, not if you, when you want to go live on air, then you put a jumper in here, and then that connects the output to the RF connector. You can also, if you want, you can use this. So if you put a jumper in the middle here, in this here to here, that will basically connect this to the 50 ohm load. So you can use this. You can use the 50 ohm load independently of everything else. So if you're testing another transmitter board for yourself, you can use this 50 ohm load. So I said we have a voltage regulator that just provides power to this, and last but not least, and so if we connect our aerial here, this is bi-directional, so the signal will go all the way in here and end up here. So this FET, if we're not transmitting, this guy we turn it off, this guy we turn it on. So it basically connects the aerial out to this RF connector, and that allows us then to receive. So rather than using relays and that, we're using a FET to switch it. So that's the basic theory of operation. Leave that one aside, and we'll look at the actual connections themselves. So there's a couple of interesting things going on here. So these are just our two control signals. One to enable the oscillator. So the oscillator 3 is connected here. And say it doesn't matter if you're using version 1 or version 2 of the RadioLab, the connections are the same. I should say this is shown for version 2, but the first stage is you build your superhet. So this without this board here, you've got just a standard superhet that you've built. You probably wonder this dangly wire, but that's actually quite important. Then, so these are the two control signals that we looked at over here. Hopefully this has been picked up. So we have our oscillator in. I'm on the 50 ohm load at the moment, and then the output just goes into the RF filter. So we connect our antenna here. So in receive mode, that basically goes through the low pass filter and into here. I've found I can bypass this filter and it works just as well. So it's because we're on the high side, I believe, of the mixing frequencies is going to be so much higher. It's not going to get through this filter, or the unwanted mixing output. So the sum of the two frequencies. So the difference gets through here just fine. So as I said, it should work as a standard superhet. And something isn't working right. Yeah, sorry, that was a bit too stupid. So, yeah, so that's the connections. So the really interesting. I've tried lots of different things here with this for the side tone, and I just go through exactly what I ended up doing. Okay, so that's where this mystery wire comes in, and so normally oscillator 2 is connected to the second double balanced mixer, and it's going to be at the IF frequency, so 4.5 megahertz approximately for version 1 and I can't even remember, it's actually 9.21 for version 2. So I was doing different things. I was using a pulse width modulator, and you could filter it, and So anytime you press the key, then you'd feed that into the audio. And just to check if it was working or not, I was using an external receiver, and then it sort of hit me. Well, if I put the signal from whatever this is transmitting in here, and I change this to the frequency that's coming out minus 6 to 800 hertz, I've just created a direct conversion receiver here. So I can actually monitor the transmission within the RadioLab. So I know it's actually transmitting, and it's not a false side tone. So that's what happens when you press this switch. The frequency of this changes from the IF frequency to, I said, just to become like basically the frequency that you'd use in a direct conversion receiver, which is, I say, 6 to 800 hertz below the receive frequency. So I just switch this back to the dummy load again for this. So now, so that's it. If you want to lower the volume, move it away. And then that's your side tone, but it's not only your side tone, it's actually just testing the receiver at the same time. So what I'm going to do now is I'm just going to basically connect up the key. So a lot of people probably want to use a key. The software is only set up for a straight key. I don't have anything else, so I'm not I don't have the software done for it, but it should be a fairly trivial exercise. There is functions there to send the dot, send the dash, send the space. So if you have a paddle, I guess you just check it. If it's the dot position, send the dot, send the space, and if it's still there, send another dot. If it's on the opposite side, send the dash, send the space, and so on. So it should be reasonably trivial to do. So the key would basically go in the same place as SW4, which happens to be 19. I have it set up that you need to pull this up, just in case something wasn't initialized. I don't want this thing just transmitting in error. So you basically connect the key to the 3V3 volts. So you can check out my Morse code skills now. So. And that didn't work. Lovely. Okay, what's going on there? So I'm into the 50 ohm load. And it's really low. And there's little or no current being drawn. So why is that? Okay, I just need to figure this out. Okay, I think it just had a loose connection there. So let me do this again. So I'm on the dummy load. What's going on here? And is my key okay? I was convinced it was 19. That's SW4. Okay. There might be a slight mix-up in the key. Let me check. Okay, yeah, that was the problem. The problem is that was for version 1 of the because SW4 was changed in version 2. So now we should be. So we have full break-in. I say I'm on the 50 ohm load, so I'm not going to. But just give you an idea. So. And then you can hear there is some small amount of leakage there. Okay, so that's the setup. So if you switch that to the live, you're good to go. I've used this to make a good few contacts, and what I found is, particularly if you're working 5 watts or so, it can be depending on the conditions. It can take a bit of time to get somebody to reply. So I think particularly on a straight key, it's constantly doing that for half an hour isn't that much fun. So I've put a CW sequencer into it. So I did have my call sign in there, and I changed it on GitHub. I said there could be somebody doesn't change the text to their call sign. There's going to be a lot of EI8KIs around. So it sends a sequence, then it delays, and you have a listen if anybody's come back. What tends to happen is that somebody will just come back, and you realize, okay, I need to stop this, and you just press S3 to stop it. So to send the sequence, press S2, and then S3 will stop it, and then you can take over and finish the QSO manually. So I hope that helps. Just again, a couple of important things. Jumpers. So but by putting the jumpers here and here, we use this. If we were to if you want to use the custom filter, we put jumpers here, and you can design your own little filter board here. On 50 ohm dummy load, this is on out to the aerial, and then if you wanted to connect the SMA to 50 ohm, so the aerial is now just connected to ground, or to 50 ohm to ground via 50 ohm, and and again, this is really important. So that goes into the input of the double balanced mixer, and you should be good to go. It's great fun making contacts on this. Although when I have to give what the rig is, it's always a bit of a dilemma, because people are expecting ICOM or Kenwood or Tentec or whatever. So I get a good few question marks sometimes on it. Okay, folks, I hope that helps. All the schematics, the connection diagrams, explanation about winding these. It's on the schematic, but there's a bit more detail up online. So that's T37-2 for these two 15 turn, and I can't even see 10 turns, and then this one has 12 turns on an FT3743. So if you wind these, put jumpers in the right place. My advice: test and stick to the dummy load, and you should be good. You should be good to go. So anyway, if you need any help, just ask on the Facebook group, and we'll happily help you out. Okay, folks. Cheers. Thanks.